All right, welcome to the conclusion of this lecture series on impulse responses and testing the real business cycle model. So far we've talked about what impulse responses are, how to interpret them, and we've talked about what the predicted responses should be for the real business cycle model, right? How does the theoretical model predict that things will, move up, down? Will they move at all? Things like that. So now that we've learned about impulse responses and the predictions of the theoretical model, now we can look at how the model actually holds up to the data. How does the data predict, or what does the data show will actually happen? So we talked about the static responses to shocks in the real business cycle model. Now we're going to look at the dynamic responses using real data and compare them and see, does the model stand up against empirical tests or does it fall short? So for the total factor productivity, or the technology shock in the real business cycle model, it predicts that we're going to have an increase in output, reduction in prices, increase in hours worked and wages, a reduction in the real interest rate, and an increase in consumption and investment. So how do I identify this? Well, this is really more for anybody who's watching the lecture that's not enrolled in the course that, is really curious about this stuff. I use sign restriction identification. So in the first lecture, when I was like, these are Bayesian credibility bands, it's because I'm using sign restriction identification, which you can either do so with a frequentist or a Bayesian approach. The Bayesian approach is a little bit easier, so tend to go with that. All right, back to we're actually learning in the course. All right. So I want to see how everything responds, and I'm going to plot these responses out for 24 quarters. Now, the signs that I impose are going to be in such a form that we have like an increase in output, price falls, hours worked, increase. So this is going to give me a shift in the aggregate supply curve and that shift in labor demand. So what were the static responses again? How do they look? Well, it looks like this. So you get the increase in production, right? That's the shock to output. Labor demand increases, so wages and hours worked increase, and then, output goes up because output went up, and the price falls. And this is what it looks like in a VAR. This is what the impulse responses are going to be like. So you get that increase in output. Okay. And I really only require the signed responses to hold for, I think it was like 3 quarters or something like that. So if it remains significant past that 3/4 mark, it's still, above 0, then we know it's kind of holding, right? It's a fairly decent model. Now, there's other ways to tell, like, if you're going for, a certain number of draws, how quickly do you get those draws? That's another way to tell whether the identification is valid or if it's like stupid. So we get an increase in output and a reduction in the price level, right? Because output goes up, price level goes down on impact, because we're looking at impact, remember. Consumption. While consumption increases, investment increases. I didn't code either of these into the identification. So you don't want to force everything to move the way it should. You want to force some things to move the way it should and see if everything else moves accordingly. So consumption and investment increase. Good. Hours worked and wages increase. I, programmed those in. The real interest rate falls. And money kind of, just stays put, right? So this would be, if you're wondering about whether, what an insignificant response looks like, it's this right here, right? Yeah, is money going up? Yes, it's above 0 for the entire time horizon. But this lower credibility band is below 0, so you can't really say what money truly did. It just kind of, statistically speaking, all you could really say is that it just stayed flat. But the real interest rate falls, hours worked, wages go up, investment goes up, consumption goes up, price level falls, output falls. Okay, so here I've got the effects of the shocks. I've got the theoretical effects and I have the empirical effects. And then this third column is whether or not it's correct. So, is this correct? Yes. output increases in both the theoretical and empirical response. So the RBC model predicts output should increase, and we see output increase. Cool. It also predicts consumption and investment should increase. But using real data, we also see consumption and investment increase. Good. Labor hours and wages. It predicts those increase, and we also see them increase. Good. So far, we're doing really well for ourselves. Let's look at the real interest rate and the price level. The real interest rate predicted to fall, and it does fall. The price level predicted to fall, and it does fall. Now, granted, I kind of coded some of these in to do that, but they remain significant in the direction they're supposed to be going for a little while after the shock as well. So that's, one of the good ways to tell you that the model does, in fact, make sense. Now, I didn't report the number of accepted draws over the total number of draws that I wanted. It's kind of outside the scope of the course, but really what you're doing is you're drawing a bunch of different samples from like a distribution of these things. And if you're like, I want 10,000 draws, but I'm going to let it run for 100,000 draws, and then you get, say, of the first 12,000 draws that you make, you get 10,000 that match what you wanted. Well, that was a pretty good model. But if you've got to go through all 100,000 to get 10,000 accepted draws, well, it's probably a fairly stupid model. So that's one way to tell. Now, I'm not reporting how many draws I made, but it was the responses came out pretty quickly. Okay, so everything kind of worked out. The real business cycle model had adequate predictions that are consistent with what we see in the real world. So the VAR gives me the same results as what the real business cycle model was telling me I should be getting. So let's do the labor supply shock. Let's look at what the static response is to a labor supply shock again. So labor supply shifts out. We move along the same production curve because there's no technology shock here, right? And then we go over and up, and we get an increase in aggregate supply and a reduction in the price level. But because we had a labor supply shock, wages fell, hours worked increased. So we have a little bit of, in terms of the qualitative responses, whether things just go up or down, right, the directions, enough of a difference that we can identify the labor supply shock and total factor productivity shocks uniquely. Okay, so here's the labor supply shock. Well, okay, output goes up, price level falls, consumption and investment increase. All right, well, that makes sense, right? Output goes up, the reduction, the price level, really just output goes up at all. You're going to see production or consumption and investment increase because there's no government spending, like, as a component of GDP here. It's just consumption and there is government spending, but it's exogenous, so it's just kind of just whatever. So consumption and investment increase. Cool. Hours worked goes up, just like we expected. Wages fall, as we predicted. Now, the real interest rate, not really a significant change in the real interest rate. You could say kind of look at it, and it looks like it falls. But statistically, we don't really have enough evidence one way or the other to say whether it went up or down. But I guess for the sake of this particular argument, yes, it does look like it went down, kind of. And then money, well, kind of stays put. So we're not really too worried about that. All right, so theoretical compared to empirical responses. Is it correct? Output goes up in both. Consumption, investment, hours worked go up in both theoretical and empirical responses. Cool. Wages, interest rates, and prices fall. Now, I kind of had to do a little bit of a stretch here on the interest rate. I know, but bear with me on this one, right? I'm not perfect. Real interest rate falls, prices fall, wages fall. So are these correct? Well, for every single one of these endogenous variables, the response is the same. At least the direction of the response is the same between the theoretical and empirical responses to these shocks. Cool. So we're 2 for 2. Awesome. So the real business cycle model predicts under labor supply shock output labor hours, consumption, and investment increase, prices, wages, real interest rate fall. VAR gives me the same results. So that's 2 for 2. We're pretty happy here. Okay, let's move on to the government spending shock. We're doing all right for ourselves. Maybe this one's going to be good too. So if you remember, government spending is an exogenous shock. Causes an aggregate demand shock because prices are flexible. The LM curve is going to shift inward. Aggregate demand shifts out, though. Vertical supply curve, output doesn't change. But because we're using estimated data, these error bands are going to need to be on either side of 0 for output for me to say there's no significant movement in output or any other real variable. So it would be like if you look at the real interest rate, right, see what that's doing, where it's moving, but the error bands are on either side of 0 for like the entire horizon. It would be the same idea as what we're looking at for output. So the idea would be we wouldn't see a significant response. Another way to look at it is look at what money does, right? Money increases, but those error bands are on either side of 0, so not really. Now, the demand shock, remember, it originates in the expenditure function. So it's happening above the aggregate demand, aggregate supply. And you end up getting the shift in the IS curve. IS curve moves out, shifts the aggregate demand curve out. And then the LM curve moves in, and then it brings the price level up to this equilibrium point between aggregate demand and aggregate supply. But no real variables have any change whatsoever. So that's what we think we should be seeing, right? If the real business cycle model works, you would have 0 responses in hours worked, wages, output, the real interest rate. Well, actually, the real interest rate would go up. So, yeah, labor hours, wages, and output would be relatively flat. Whoa. That is not what we're seeing here at all. Okay, geez, what's going on? Output. What does output do? Well, output increases, and it's pretty significantly above 0 for almost the entire horizon. Price level. Price level also goes up. Well, we expected this one, right? We expected the price level to go up because the model suggests price level should go up. Predicted that. So that's not too much of a shock. Okay, consumption and investment. Well, didn't we predict that like consumption and investment would both fall? Or some combination of the two would lead to a reduction in output? Oh, God. None of that makes sense. Oof. So output goes up, consumption and investment both go up. How about that? All right. What about hours worked? Oh, shit, those increase too. Wages increase. Oh, boy. Then the real interest rate goes up, and we have like a negligible response in the money supply. Okay. This didn't line up at all with what we thought we'd be seeing. Did not work. Okay, that's not what the real business cycle model at all predicted would happen. Output went up. I mean, the real interest rate increased. Well, actually, okay, so we did expect the real interest rate to go up. Hours worked, wages, consumption, investment, they all went up. Almost none of the real variables responded how they should have. It did predict the real interest rate went up, so at least there's that, I guess. So the theoretical response said output should have no change, consumption and investment would fall, no change in labor or wages, real interest rate and prices would both go up. What did the empirical response tell us? Well, showed me output went up. That was not correct. Real business cycle model didn't get that one right. Consumption and investment, those both went up. Nope, that's not in line with the real business cycle model at all. Labor hours, wages. Oh, oops, that's a little mistake on my part. It's supposed to be a plus there, not a minus. Oopsie. So I'll keep the little mouse cursor there so it looks like a plus. All right, cool. So labor hours, wages both increased. Nope, that didn't line up. Real interest rate and price level, those both go up, and that was consistent with what the real business cycle model predicted. So 2 out of 7? I guess it's better than 1 out of 7 or none out of 7. Hey, whatever. All right. maybe money supply shock's going to work a little bit better. Kind of like my last ditch effort here to see if this works. What's going to happen? Well, the real business cycle model says the LM curve shifts out when the money supply goes up. And it's going to shift aggregate demand out. And then the shift in prices, well, prices are perfectly flexible. So prices are going to go up immediately. Aggregate demand doesn't, shift back in. It stays out. And the money supply shock should increase demand, but output doesn't move. Why wouldn't it move? Because we have a vertical aggregate supply curve. So if anybody's like, I want to use monetary expansion to try to boost output, there's no mechanism for monetary expansion to alter any real variables. So the static response would be this. Now remember, you still got some stuff going on above the aggregate demand, aggregate supply space, which would be giving us a way to uniquely identify a monetary policy shock from a government spending shock, but that's neither here nor there. You know what the signed responses of those should be. This is what it should look like. This is what we should be seeing. So what happens under a monetary policy shock? Okay, well, the order of these things change a little bit. It doesn't really matter at all. Just, I guess, worth pointing out. So the money supply increases. Well, that one happens by construction. The real interest rate falls. Whoa, that wasn't supposed to happen. The nominal interest rate was supposed to fall, but the real interest rate was supposed to stay put because the increase in prices would offset that increase or the decrease in the nominal interest rate. But I guess if prices aren't totally flexible, what else is it? Oh, wow, output goes up then. So if we don't have totally flexible prices, output increases. And if output goes up, well, consumption and investment both go up. Consumption's going up. Well, people want more consumer goods. They want more stuff. How do you get more stuff? Well, you have to make it. How do you make it? Well, you need more workers. How do you get more workers? You pay them more. So this is telling me, really, if we want to think about this for a second, that prices aren't totally flexible, maybe. Because if prices were totally flexible, there'd be no response in output. And if there's no response in output, consumption, investment, hours worked, and wages wouldn't move. And as such, the real interest rate wouldn't be falling. It would stay put because the reduction in the nominal interest rate would be equal to the increase in the price level. So this is telling me I can deduce using my Sherlock Holmesian deductive reasoning that what's likely happening is that prices aren't totally flexible. They're not fully flexible here. What's the alternative then? Well, prices are sticky. There's what's known as a nominal rigidity. And that nominal rigidity, that sticky price component, isn't in the real business cycle model. But the real world data is telling me that it's there. So if it's there, but the real business cycle model is saying it isn't, but the real world says that there is, there's a problem here. The real business cycle model is not working all that well. Because if this had worked in our favor, we could have had a good, nifty little celebratory boogie. It would have looked like this. But in reality, what's happening is what you have on that little Bunsen burner is producing all sorts of noxious chemicals, and you're smelling them while you think you're doing your little celebratory boogie, but in reality, it's producing some sort of a hallucinogenic compound that you're breathing in and taking into your body. And when you do that, it ends up looking like this, and they have to call animal control to come fix the problem and remove you from the situation. By the way, this show is fantastic. It's called The Amazing World of Gumball. Great show. It's one of those shows that's marketed for kids, but it's really not a kids show. It's actually more like the humor gets a little adult sometimes. It's a great show. Highly recommend. Maybe not for kids, but definitely recommend the show. All right, so let's compare what the monetary policy shock under the real business cycle model predicted versus what we get using real data. And is this correct or incorrect? Well, with the increase in the money supply, the only thing that was predicted of these 7 endogenous variables, the only thing that was predicted to move at all was the price level. Price level increases. Everything else has a zero response. Empirically, what do we see? Well, output goes up, consumption and investment increase, hours worked increase. I don't know why I've got the negative there for wages. It's supposed to be positive. There. Put the mouse there again. Okay. Wages also increase, and the real interest rate falls. So of these 7 endogenous variables, I only got one of them right. And that's the price level. Everything else increased with the exception of the real interest rate. Wages increased. I know that the slide says it decreased. That was just a typographical error on my part. Wages actually increase. Hours worked increase. Investment, consumption, and output all increase. So what does that tell me? Well, it tells me it didn't really work for the money supply shock. So neither the government spending nor the money supply shock worked all that well. Those are both demand side shocks. And the model doesn't work for that. It's interesting. Works awesomely for supply side stuff. That's great. Just doesn't really do a whole lot for demand. But don't really worry just yet, because there's something interesting going on. What is it? Well, it's actually these long run responses. So the short run, right? I'm just going, does this go up? Does this go down on impact? Those didn't really line up all that well. Let's look at the money supply shock, though. What's going on? Well, if you notice, everything is kind of trending towards zero. Hours worked eventually trend back towards where they were. Wages, I guess, kind of fall. They increase. But if you were to draw this out a little bit further, they would kind of go back towards zero. As prices increase, well, let's see, investment falls, consumption falls, output, you don't see it get back to zero here, but it does eventually return to zero. The real interest rate, that returns back to where it was. Okay, so it looks like for the most part, maybe the time horizon was a little too short to show everything, but for the most part, things really kind of start to return to where they were prior to the shock. So the real variables are mostly all decreasing and trending towards zero. So in the long run, or even really the medium run, like say medium to long run, the real variables are returning to their steady states. So in the medium to long run, we have monetary neutrality. Okay, well, let's think about monetary neutrality for a second. You're going to have an increase, a one-time increase in the money supply, and the steady state values are all unaffected. That's interesting. Let's think about that for a second. The steady state values of the real variables will be unaffected for a one-time increase in the money supply. Okay, let's look at the theoretical response over here for a second. Think of these as steady states rather than like just, where they are right now. Right? Think of them as in the steady state. What happens? Steady state output, no change. Steady state consumption, no change. Steady state investment, no change. Steady state hours worked, no change. Steady state wages, no change. Steady state real interest rate, no change. Steady state prices, or I guess really in the real business cycle model as we saw it, steady state inflation, it does go up. That actually does make sense. All the nominal variables move, the real variables are unaffected. So in their steady states, or like in their long run behaviors, real business cycle model does seem to work. That's cool. So maybe, just maybe, the real business cycle model does kind of work, sort of. It allows for demand side shocks to have real effects in the short run. Okay, the real business cycle model doesn't allow for that. We need a model that allows for that, because it doesn't allow for that, but we see it. But it does work in the long run. In the long run, if we were to trace those impulse responses out for, 30 quarters or 40 quarters, everything would kind of trend back towards zero, back to where it all started from, right? So in the long run, the real business cycle model's predictions work. They just don't work in the short run. So we need something in the short run that does work, that will work for us, that will give us qualitative responses similar to that of what we see in the real world data. Now, we're not the first people to think about this. There are a lot of others who did decades ago. And they developed the new Keynesian model, which allowed for these demand-side shocks to have real effects. And it works really through a number of differences. The biggest one is that prices are sticky. If we allow for sticky prices, well, we kind of have to relax the assumption of perfect competition. But if we relax those assumptions and maybe a couple other small ones, we can get a whole range of new results. And that's actually what the new Keynesian model will cover. Now, before we go any further, though, there's one thing I want to talk about really quick. This model, the real business cycle model, came out in like the early 1980s or so. Now, in the 1970s, there was a big problem with stagflation. There was high unemployment and high inflation. Now, the existing theory suggested that there was like a trade-off between inflation and unemployment that was represented through what's known as the Phillips curve. The idea is if the central bank inflated the money supply, it could trigger an aggregate demand shock. If prices weren't flexible, output increases, meaning unemployment falls. Firms need more workers to be able to produce like more stuff. Now, people figured out what was going on. They started to adjust their expectations to the inflationary pressures, and before long, inflation didn't influence unemployment, so central banks were like, screw it, we'll just go like all Leroy Jenkins on this and increase inflation even more. You end up with double-digit inflation rates and high unemployment. It's what's known as stagflation. It's really, really, really bad stuff. Now, I guess really this last bullet I probably should have removed for this course. The expectations augmented Phillips curve in the Barrow and Gordon model. You guys aren't going to be seeing that in this class, but it is there. If you take my money in banking course, you will see it. So that is kind of where the expectations started to come into play. We ended up with something known as rational expectations, which the real business cycle model and new Keynesian models both operate under. Now, in the 1970s, Robert Lucas published a lot of papers, eventually known as the Lucas critique, and it stated a lot of the previous economic models had endogeneity problems and they couldn't be used for policy implications. And that's one of the reasons why the real business cycle model came out. It was a first attempt at making a model that fixed these endogeneity problems, and it fixed them quite well. But the thing is, you kind of have to start simple. You can't go too advanced too fast. Make sure the simple stuff works first, and then see where the simple stuff works, see where it doesn't work. Where it doesn't work, make tweaks to try to get it to fit things a little bit better. How do we get this to explain the real world a little bit better? Now, in the meantime, what do you know? Radical change in the slide just happened out of the blue, just magical. Actually, it fixed a historical inaccuracy. I guess I got tired of having mistakes in the slide here. I finally decided to fix it. Reagan was elected in 1980, took office in 81, and he stuck with Paul Volcker as Fed chairman. Turns out Jimmy Carter actually appointed him. For some stupid reason, I thought Ronald Reagan did. I was wrong on that part. Decided to fix that. So Jimmy Carter appointed Paul Volcker. Reagan stuck with him, and what Volcker did was he aggressively cut the money supply to try to curb inflation. Unfortunately, it triggered a recession. But when the economy responded to the shock, eventually it went back to normal, and we had low unemployment, or low inflation and low unemployment throughout the majority of the 1980s. Now, again, this is when the real business cycle model is really starting to come out. It picked up a lot of traction because it seemed to describe the economy pretty well. Now, a lot of the policies that were enacted throughout the 1980s were also supply-side policies. They were focused on supply-side factors. And they really worked as the real business cycle model would have predicted. These supply-side policies fit for a model that really describes supply-side shocks or real shocks rather well. Now, unfortunately, this is, I try not to get political with these lectures. Unfortunately, sometimes you just can't really help it because that's just the nature of the beast. When you're teaching macroeconomics, you tend to get into politics pretty quickly. And this is something I really want to address. So you've probably heard like trickle-down economics or Reaganomics. Or I think nowadays they're trying to call them like Trumponomics or something. And again, not trying to be too political here, but Democrats will always go, "Oh, trickle-down economics, it doesn't work. We've tried it and it's failed. It hasn't worked." Okay. Well, this is where politicians lie. Oh, whoa! Who would have thought politicians lying? Wow, that's never happened in the past. They like to play semantic games here, word games. And they'll take something, they'll change the name, and make you think that what they changed the name to is the same as what they initially ran with, but then they change the implications of what the thing is once they change the name, but they don't really tell you that part. So they'll tell you trickle-down economics and supply-side economics are the same thing. I mean, why wouldn't they be? You'd think it's the same, right? Well, if you get tax cuts and you get all these supply-side policies, it's going to promote business, and you want, a good, healthy business environment. But when you do that, the businesses just grow, and the gains from all this production don't ever trickle down to the workers or the poor or the middle class. And instead what happens is the rich just get richer. So if you have all these supply side policies, all that you do is you just make businesses richer and everybody else gets poorer. Right? That's kind of that like myopic worldview that Democrats will love to try to push when they're attacking Republican candidates or Republican policies. But here's the thing. Supply-side economics and trickle-down economics are, in fact, not the same thing. Trickle-down economics, well, that's that myopic worldview I just shared with you about basically the end of the world from trying to cut tax rates or something like that. Supply-side economics, all it says is that a majority of variation in GDP can be described by supply-side shocks. Nothing more, nothing less. A majority of the variance, a majority of the movement in GDP is explained by supply-side shocks, and then thus a minority of the movement in GDP or the variation in GDP is described by demand-side shocks. This model just says supply-side shocks influence the business cycle. It doesn't mean that we need to give more money to the rich and see wealth try to trickle down to the poor. What variables would even say that in the model? What equations would even say that in the model? Try to find the equation. I'll tell you it's not there. The model and the school of thought that followed it was like ruthlessly attacked because it was confused with trickle-down economics because, lo and behold, politicos took supply-side economics, gave a really simplistic, pathetic interpretation of what it is, and then we're like, oh, what do you know? That is... We're calling it trickle-down economics, but clearly it's just the same thing as supply-side economics, and they just don't think that you're ever going to be smart enough to ever learn what the difference is. Lo and behold, now you do know what the difference is. Supply-side economics is a thing. Trickle-down economics is not a thing. That's just garbage bullshit that was produced by non-econ academics, media, lying politicians, just people that you probably shouldn't be listening to anyways. Because all the real business cycle model and all supply-side economics ever says is that supply-side shocks account for more of the variation in GDP than demand-side shocks. That's it. That's all it is. So hopefully now you learned something. So now we get to wrap up. We tested the real business cycle model. Seems to work well for supply-side shocks, at least in the short run. Demand-side shocks, not so much. So it's not a bad model. It just doesn't tell us the whole story. And we need a model that maybe can tell us the whole story. Because the real business cycle model works very, very well for supply-side shocks and even demand-side shocks just in the long run. We need something to work in the short to medium run, though. So maybe overall the real business cycle model just works in the long run or the medium to long run. And we need something to work in the short to medium run. And if we get something that works in the short to medium run but maybe converges to the same long-run predictions of the real business cycle model, maybe then we're in business. Maybe then we actually have a pretty decent story of at least the two different classes of business cycle models. So we've got the class of real business cycle models, which we just wrapped up. And then we're going to be moving on to the class of new Keynesian models. So the next lecture is going to be talking about the new Keynesian model. And that's going to help us answer some of the questions that the real business cycle model failed to answer. And the new Keynesian model is going to be very useful for the short to medium run. And the implications of the new Keynesian model will be such that as we move to a long run equilibrium, it ends up being the exact same thing as what we have in the real business cycle model. So, with all of that said, everything out of the way, this wraps up the material for the real business cycle model. This actually also wraps up the material for exam 2. So be on the lookout for exam 2. It will be coming soon, maybe with a study guide to help you out first. And that'll be that. So thank you for watching this. I hope you enjoyed all of it, and be on the lookout for more work and more lectures.